National Electrical Code Section 250.32b3 addresses grounding and bonding requirements for detached buildings or structures. It specifically mandates that the grounded conductor, commonly referred to as the neutral conductor, must be continuous throughout its entire length. This means that the neutral conductor cannot be interrupted or terminated at the detached structure, but must instead extend from the originating source, typically the main service panel in the house, to the detached building without any breaks. The purpose of this requirement is to maintain a low impedance ground fault current path. This path is essential for the proper operation of overcurrent protection devices such as circuit breakers or fuses. When a ground fault occurs, a large current flows through this path back to the source, causing the overcurrent device to trip and to energize the circuit, thus preventing electrical shock hazards and minimizing the risk of fire. If the neutral conductor is interrupted, the ground fault current path is compromised. This can result in a situation where the fault current isn't sufficient to trip the overcurrent device, leaving the circuit energized and posing a significant safety risk. In the specific scenario of wiring three-way switches for exterior lights on a detached garage, it is crucial to adhere to this requirement. A three-way switch circuit allows a light to be controlled from two different locations. Typically, this involves running a 3-conductor cable plus ground between the two switches and the light fixture. The correct way to wire this circuit in a detached garage situation is to run a 3-conductor cable plus ground from the house to the garage. This cable carries the hot conductor, the switched hot conductor, the traveler conductors, and the neutral conductor. At the garage subpanel, the neutral conductor from the house must be connected to the grounded conductor busbar. This busbar is bonded to the garage grounding electrode system, ensuring a continuous and effective ground fault current path. The inspector's suggestion of running number 14 American wire gauge THW and conductors through polyvinyl chloride conduit to the house, pulling hot conductors from the house and grounding to the house, while keeping the neutral in the garage, is a violation of National Electrical Code Section 250.32b3. This method interrupts the neutral conductor at the detached garage, which is expressly prohibited. Using the existing 6 number 14 American wire gauge wires as runners to pull hot conductors from the house and grounding to the house, while maintaining the neutral in the garage, also violates this requirement. This approach creates a situation where the neutral conductor is not continuous from the house to the garage, compromising the ground fault current path. To ensure compliance with the National Electrical Code and to maintain electrical safety, the neutral conductor must be continuous from the house to the garage subpanel. This can be achieved by running a 3-conductor cable plus ground from the house to the garage and connecting the neutral conductor to the grounded conductor busbar in the garage subpanel. This busbar is then bonded to the grounding electrode system, providing a complete and effective ground fault current path. In summary, interrupting the neutral conductor at a detached garage is a violation of National Electrical Code Section 250.32b3 and can create a hazardous situation. The correct way to wire 3-way switches for garage exterior lights is to run a 3-conductor cable plus ground from the house to the garage, ensuring a continuous neutral conductor. By following these guidelines, you can ensure electrical safety and compliance with the National Electrical Code. Additionally, it's important to understand the specific components involved in ensuring proper grounding and bonding in a detached garage. The grounding electrode system in the detached garage typically consists of ground rods, ground rings, or other approved grounding electrodes. These electrodes are connected to the grounded conductor busbar in the subpanel, providing a direct connection to earth. This connection helps to stabilize the voltage to ground and provides a low impedance path for fault currents. The equipment grounding conductors, which are the green or bare wires in the electrical circuits, are connected to the equipment grounding busbar in the subpanel. This busbar is also bonded to the grounded conductor busbar, creating a common grounding point for all electrical equipment in the garage. When a fault occurs in an electrical device, the fault current flows through the equipment grounding conductor back to the subpanel and then through the grounded conductor to the source. This high current flow causes the overcurrent device to trip, disconnecting the circuit and preventing electrical shock. The size of the conductors used for grounding and bonding is determined by the size of the service entrance conductors or the feeder conductors supplying the detached garage. National Electrical Code Table 250.122 provides guidance on the minimum size of equipment grounding conductors based on the rating of the overcurrent protective device. It is essential to use the correct size conductors to ensure that the ground fault current path has sufficient capacity to safely carry the fault current. Furthermore, it is crucial to ensure that all connections are made properly and are securely tightened. Loose or corroded connections can increase the impedance of the ground fault current path, reducing its effectiveness. Regular inspections and maintenance can help to identify and correct any potential issues. When running conductors in polyvinyl chloride conduit, it is important to follow the National Electrical Code requirements for conduit fill. Conduit fill refers to the percentage of the conduit's cross-sectional area that is occupied by conductors. National Electrical Code Chapter 9, Table 1 provides guidance on the maximum allowable conduit fill for different types of conduits and conductors. Exceeding the maximum conduit fill can make it difficult to pull conductors through the conduit and can also lead to overheating of the conductors. In addition to the grounding and bonding requirements, it is also important to consider the other electrical safety requirements for detached garages. These requirements include the use of ground fault circuit interrupter protection for receptacles located in damp or wet locations, such as outdoor receptacles and receptacles in the garage workshop. Ground fault circuit interrupters are designed to detect small ground faults and quickly interrupt the circuit, preventing electrical shock. It is also important to ensure that all electrical equipment is properly listed and labeled by a recognized testing laboratory, such as Underwriters Laboratories. This listing indicates that the equipment has been tested and meets safety standards. Finally, it is always recommended to consult with a qualified electrician to ensure that all electrical work is performed in accordance with the National Electrical Code and local electrical codes. A qualified electrician has the knowledge and experience to properly design and install electrical systems and to ensure that they are safe and compliant. In conclusion, proper grounding and bonding are essential for electrical safety in detached garages. Following the requirements of National Electrical Code Section 250.32b3 and other applicable codes can help to prevent electrical shock hazards and minimize the risk of fire. Remember to maintain a continuous neutral conductor from the house to the garage, use the correct size conductors for grounding and bonding, and ensure that all connections are made properly. By taking these precautions, you can create a safe and reliable electrical system for your detached garage. The information provided here is for general guidance only and should not be considered a substitute for professional electrical advice. Always consult with a qualified electrician for any electrical work. To elaborate further, the concept of impedance in the ground fault current path is critical to understanding the effectiveness of the grounding system. Impedance is the total opposition to current flow in an alternating current circuit, and it includes resistance, inductive reactance, and capacitive reactance. A low impedance ground fault current path allows a large fault current to flow quickly, tripping the overcurrent device. Conversely, a high impedance ground fault current path restricts the fault current, potentially preventing the overcurrent device from tripping. Several factors can contribute to high impedance in the ground fault current path. These include undersized conductors, loose or corroded connections, long conductor lengths, and improper bonding techniques. To minimize impedance, it is essential to use the correct size conductors, ensure that all connections are clean and tight, keep conductor lengths as short as possible, and use proper bonding techniques. Bonding refers to the connection of metallic parts to create a continuous electrical path. In the context of a detached garage, bonding is required between the grounded conductor busbar, the equipment grounding busbar, the metal enclosure of the subpanel, and any other metal parts that are likely to become energized. Proper bonding helps to ensure that all metal parts are at the same electrical potential, reducing the risk of electrical shock. The National Electrical Code provides specific requirements for bonding in Section 250.92 and 250.96. These sections outline the methods and materials that are acceptable for bonding. It is important to follow these requirements carefully to ensure that the bonding is effective. In addition to bonding, surge protection is another important consideration for detached garages. Surges are transient overvoltages that can damage electronic equipment. They can be caused by lightning strikes, utility switching, or other events. Surge protective devices are designed to divert surge currents away from sensitive equipment, protecting them from damage. Surge protective devices should be installed at the main service panel in the house and at the sub-panel in the detached garage. This provides multiple layers of protection against surges. The National Electrical Code provides requirements for surge protection in Section 230.67 and 285. These sections outline the types of surge protective devices that are acceptable and the installation requirements. Furthermore, it is important to consider the environmental conditions in the detached garage when selecting electrical equipment. If the garage is damp or wet, it is necessary to use equipment that is rated for wet locations. This equipment is designed to withstand exposure to moisture and prevent electrical shock. The National Electrical Code defines wet locations and provides requirements for the use of equipment in these locations in Section 406.9 and 410.10. In addition to wet locations, it is also important to consider the presence of flammable materials in the garage. If flammable materials are present, it is necessary to use equipment that is rated for hazardous locations. This equipment is designed to prevent ignition of flammable materials. The National Electrical Code defines hazardous locations and provides requirements for the use of equipment in these locations in Article 500 through 516. It is crucial to properly classify the hazardous location and select equipment that is suitable for that location. The classification of a hazardous location depends on the type of flammable material that is present and the likelihood of its presence in an ignitable concentration. Finally, it is important to remember that the National Electrical Code is a minimum safety standard. Local electrical codes may have additional requirements that are more stringent. It is always necessary to comply with both the National Electrical Code and the local electrical codes. Consulting with a qualified electrician can help to ensure that all electrical work is performed in accordance with all applicable codes and standards. The role of the electrical inspector is to verify that electrical installations comply with the National Electrical Code and local electrical codes. The inspector reviews the plans for the electrical system and conducts inspections of the installation to ensure that it meets the code requirements. If the inspector finds any violations, they will issue a notice of violation and require the corrections to be made. It is important to cooperate with the electrical inspector and to make any necessary corrections in a timely manner. The electrical inspector is there to protect the safety of the public and to ensure that electrical installations are safe and reliable. Therefore, ensure continuous improvement by keeping abreast of any changes to the National Electrical Code.